My name is Monty Pridgeon. I work with Deutsche Beverage Process. I'm a technical sales manager, and we're here to talk about an exciting product group within our company. I'm sitting right here with Joel Cardona. Did I say that right?
Yes.
Perfect. Who actually is an applications engineer with a membrane technology that can remove dissolved oxygen and have a lot of other applications. But the brand is called Liqui-Cel. So I guess to kick it off, if you want to tell me a little bit about yourself and a little bit about kind of what you've done with the company and a little bit about the technology.
Certainly. So my name is Joel Cardona. I have been with the Liqui-Cel product line for 18 years in not only manufacturing, also in technical sales, and recently, actually over the last 10 years, I've been working as an applications engineer in our laboratories and in the field.
Excellent. Great. So obviously you've got a really strong background with this Liqui-Cel, product. Can you, how would you explain what Liqui-Cel is?
So Liqui-Cel, essentially, it's a membrane contactor. Mm-hmm. The idea is to bring two faces together that are immiscible, but bring them into contact with each other without necessarily allowing them to mix. Okay. The main purpose of Liqui-Cel typically is to control dissolved gases within a liquid.
Perfect. Okay.
And that application, whether it is to introduce gases into the liquid or to remove dissolved gases from the liquid, that is the core function of a Liqui-Cel membrane contactor.
Okay, perfect. And that makes good sense because obviously you started with the more technical side. I appreciate you breaking that down a little bit simpler. So, and how long has Liqui-Cel been producing these contactors?
So Liqui-Cel has a history of nearly 4 decades producing these membrane contactors for, as I mentioned, debubbling applications or very specific degassing control.
Gotcha. Okay. That makes perfect sense. And then, so I know that obviously you guys are located in the United States. I assume you sell these globally. They're produced all over the world as well. Is that kind of the general?
Yeah, so our products are produced in 2 primary locations. One is in Charlotte, North Carolina.
Okay.
And that's our one of our production plants. And we also have a production plant in Wuppertal, Germany.
Okay.
As
Excellent.
well.
Got you. Okay. And then I guess the final question as we kind of start this conversation is, I do think it probably makes sense to explain why we're both sitting here together. So our relationship is that they actually manufacture the Liqui-Cel products. We build stainless liquid processing equipment. So we essentially take their products and we build more or less skid-based systems that house their product and that add all the additional valving, piping, instrumentation, anything else needed to allow the product to work seamlessly in multiple different applications. But one question I've got is, you guys have been manufacturing this product for, like you said, 4 decades. Why did you choose, why are you working with Deutsche? Why did you choose to work with other companies to build these skids?
Certainly. So integrators like Deutsche Beverage are a fundamental part of our business ecosystem. The idea is that we provide the best membrane contactor in the market, but that membrane contactor has to be integrated into a full solution for the customer. And in order to do that, really, the system integrators have the know-how to really build the entire package solution for the customer.
Perfect. No, and that makes sense. And quite frankly, we actually have one on the floor. So as soon as we finish this conversation, we'll get out there and obviously we'll kind of walk you through what the technology looks like when it's put into the skid. We'll kind of identify probably the main components that make it work. And we built that one specifically to remove dissolved oxygen. I know obviously they can obviously function in a lot of different ways, putting gases back in, taking other gases back out. So maybe we can even talk a little bit about maybe what would be different in those scenarios.
Sure.
But kind of transition to the next topic. A couple things we wanted to accomplish today is explain how the technology works, kind of where it's needed, why it's needed really, and then some technologies that we could potentially replace, utilizing just a simple membrane contactor. So to kind of kick it off, and I think a lot during this conversation, I know that you guys can use this contactor in a lot of different places. We'll be speaking as it relates to a lot of the beverage market. I guess we'll touch in a minute on the different markets that you can work with. But I guess the first conversation point, or the first thing to kind of go over, would be, how does this work? So it's we keep saying it's a simple technology. Why is it a simple technology? How does it work? What does it look like? What could you compare it to kind of explain it?
So probably the most direct comparison when it comes to, at least in the beverage industry, would be a deaeration tower. That would be the direct replacement, is a membrane contactor.
Okay.
The way it works, the Liqui-Cel membrane contactor, as the liquid phase is flowing into the device itself, it comes into contact with a membrane bundle.
Okay.
This membrane bundle is composed of thousands of hollow fibers.
Got it.
These hollow fibers really serve as the interface between the liquid phase and the gas phase. Okay. The membrane is hydrophobic in nature, so it doesn't allow the bulk liquid to come across the hollow fibers.
Okay.
But then, as you're separating the two phases, the inside of the hollow fiber, you can modulate the pressure, the gas pressure inside of it, creating a partial pressure differential.
Like, I guess, a favorable environment?
A favorable environment, which then would actually allow gases that are in solution to either come out, or if you want to introduce gases, the opposite can also occur.
So I guess then, if I'm understanding correctly, and maybe a simple way to kind of put this, so we have a contactor, a round cylindrical object that we're essentially made up of all the hollow fibers. We're passing liquid through in one direction through this contactor, almost like a shell and tube heat exchanger almost, right?
Absolutely.
And the liquid would be what, on the shell side?
It would be, the liquid would be on the shell side.
Perfect, okay.
And the gas side would be on the interior of the hollow
So
fiber.
in the tubes, essentially, right? Which would be inside the hollow fibers, perfect. And then your gas is basically flowing through, and I assume that those are probably flowing countercurrently.
Yes,
And
countercurrent flow.
Perfect. And so when you set up a favorable environment, that allows for you to physically pull the gas in or physically pull the gas out of the water or the bulk material you're talking about.
That is correct.
Perfect. That makes perfect sense. And so I guess the next question is kind of, where all would you want to use this product? Where all is this applicable to? What all?
So in terms of applicability, pretty much any industry that requires dissolved gas control, whether it is for deionizing water, whether it is for removing dissolved oxygen in order to make products that have long longevity at the shelf life longevity, pretty much can benefit from Liqui-Cel technology.
So what are some of the main industries that you guys tend to sell this product into?
Typically, the main industries will be microelectronics are a big customer of ours. Beverage, obviously, another big customer of ours. Power industry, power and steam production, where oxygen can be problematic in terms of producing corrosion.
Okay, yep, makes sense.
And then last but not least would be industries, for example, like printing, where you have very rapid printing, and bubbles within the ink can cause defectivity.
Oh, yeah, that makes perfect sense, yeah.
Within the printing process.
Basically take out the bubble, so it's just a smooth liquid feeding in.
Exactly.
That makes good sense. And obviously, so our background, our origins are in beverages. So I guess talking a little bit about the beverages, what are some beverage applications that we can look at this in?
So in terms of beverage applications, the primary beverage application, I would say, it's deoxygenation of water, push water or blending water, whether it is for brewing or for the production of wines. But other applications that are common, for example, would be the utilizing the Liqui-Cel contactor to introduce carbon dioxide into wines and making sparkling wines. That would be another popular application that we have been involved in. And then another popular application that has been gaining some traction recently is the dealcoholization of adult beverages as well.
So what role, what role does this play in dealcoholization?
So in dealcoholization, the idea is that the contactor is able to be utilized to remove the alcohol in very much in the same way as in the process of osmotic distillation.
Okay, excellent. So in terms of, we've obviously talked about different drinks and different materials. Can you physically, flow, we talked about the bulk side of this membrane. Can you, are you only flowing the water through? Or are you flowing the actual end product, whether that be beer or a soda or a wine?
It depends on the application. And for example, in the, I'm sorry.
You're good. You're doing, this is going really well, by the way. Great job.
If you're adding a CO2 into a wine, you can actually flow the entire, the wine itself through the product and then introduce the CO2. The membrane is made out of polypropylene, so there are very, no leachables or anything.
Yeah, food safe, right? It's food safe. That makes sense.
Food
okay.
Grade, yeah. In the case of push water or blending water, you would just have the water that is ready for prior to fermentation. Mm-hmm. You would just deoxygenate it at the proper temperature and then utilize it from there.
So in a lot of beverage situations where a customer's making a concentrate on the front end, where sodas, energy drinks, beer, breweries, whatever that may be, they basically would take this water, deaerate it, and then right as they're feeding the filler, when they're basically putting that blend water back into solution, it comes in deaerated. Obviously, there's a small amount of non-deaerated, concentrated solution. Basically, mix those together the right ratio, and then you have a mostly deaerated product.
Yes, that is correct.
Makes perfect sense. So we talked a little bit about the applications. I mean, obviously we have the deoxygenation. We can carbonate. We can add nitrogen, take CO2 out. Obviously O2 removal in the bottling of the canning process. What are the features and benefits specifically of using this membrane contactor? I mean, tell me a little bit about give me a little bit of the sales pitch side. I can think of a couple in my head, but obviously you're the expert. Love to hear your thoughts.
So the primary advantage to Liqui-Cel is its size. So you're able to get the deaeration needs met in an extremely compact packaging.
Oh, and that's perfect because we'll actually go look at it. I mean, physically they are very, very small.
The other aspect of it is that with the Liqui-Cel contactors, you are able to operate at pressure, so there's no additional pumps or repressurization pumps that would be necessary that are typical of a tower type installation.
That makes perfect sense. And one advantage that I think we've seen a lot of, and maybe you can expand on a little bit, is it seems like a very controllable process. So it's direct in line. It's essentially you start feeding water, you start feeding the gas you're trying to take out or you're trying to add to it. Obviously, there's a couple other pieces you got to turn on, but once you turn it on, you just can walk away. I mean, it's direct, it's in line, and it just runs.
That it does. It requires very little human interaction once the process is set up, and the contactors themselves, since there's no mechanical parts, no moving parts within them, there's very little maintenance other than your typical cleaning.
Which you'd probably be doing anyways in the facility.
Correct.
That's exactly right. Now, talk to me a little bit about, the ability to kind of predict how these are going to work. So, I have an application. I've got a flow rate I need to meet. I know I've got a end goal of what I want. Let's talk about a dissolved oxygen removal system, right? I'm flowing in at X, flow rate, we'll say 50 GPM. I want to go from saturated water down to a certain ppb level of dissolved oxygen. Are you guys able, how are you able to kind of predict what type of membranes I need or what size? I mean, what does that look like?
So we actually have a software called GasCAD. that is utilized by our integrators as well as internally for us to provide the answers to those very questions, those design questions for our customers. And that software is able to tell you to predict the concentrations of the various gases that you're trying to either remove or add, as well as vacuum pump sizing and pressure drops through the contactor. So we have a pretty extensive suite that we have built over the last 25 years. That data is actually collected every. That data is collected in our labs here in Charlotte, and it's used to characterize our products and able to bring the customer a very accurate picture of what they will need when designing with a Liqui-Cel contactor.
No, I mean, that makes perfect sense. And so far, obviously pretty compact, small, pretty easy to get running. Once you have it set up, they just run. There's really no interaction required. It's very predictable.
Yes.
I guess in terms of one of the other thoughts that customers tend to have, or people that are in operations or manufacturing, operations costs. I mean, is there once you get it set up? I mean, tell us a little bit about how long do these theoretically last? What kind of costs would I expect as a customer? Because I know when you have a tower, I mean, you have heating costs. You've got you've kind of got all these different costs that can go to add into that. But tell me a little bit about the ongoing costs of this membrane technology.
So the membrane technology itself, the cartridges tend to last somewhere in the 3 to 5 years, depending on the water quality that is coming into the process. The better the water quality, the longer they last. We have seen some applications where these contactors can last in excess of 5 years. But in the case of the beverage industry, where typically the water may not necessarily be RO
Gotcha.
always, that time frame can be in the 3 to 5 years.
Got it. And I guess, is the primary concern just plugging those kind of hollow fibers where you have that gas water exchange?
Yes. So the primary concern would be fouling or
Okay.
particulate contamination. So pre-filtration of these contactors is a fundamental need when utilizing Liqui-Cel membrane contactors.
And you guys also have a pre-filtration, or not pre-filtration, but a filtration equipment line as well.
Yeah.
High flow, correct?
High flow is the preferred pre-filtration device prior to Liqui-Cel, and certainly used in many of the beverage industries currently.
Perfect. So filter it up front, ensure that the membrane stays clean, every so often run a cleaning process, and then you're up and running for 3+ years.
Absolutely.
Perfect. Well, understanding how it works, understanding the advantages of it, it kind of leads to the question of what are the other technologies that are out there in the market that this maybe can beat, and then maybe we can even circle back and say why we theoretically like the concept of this, or maybe why we would find this, our customer would find this attractive compared to some other technologies out there.
So I think the primary technology that we replace is the vacuum tower or deaeration towers. And again, the membrane area to volume ratio is 10x on a membrane contactor. So the size is much smaller.
Right.
Also, the additional cost of pumps is not necessary.
Because you have to pressurize those so much.
Right.
Understood.
So that, at least in the beverage industry, those are or the towers will be the primary technology that we would replace. In other industries, we would reduce the chemical cost of either using oxygen scavengers or using ion exchange beds for removal of certain ionic load species like CO2.
And I would also assume, even in the carbonation, or when you're adding basically CO2 to a solution, is it more efficient than just like a standard carb stone?
It is not only more efficient, but I think where our customers get the most value from the Liqui-Cel is really the very precise control, right? It's the consistency of product that most of our customers are looking for. And this is absolutely true in the wine industry where the customer wants every single bottle of wine to have that very specific carbonation, that very specific taste. And Liqui-Cel brings that to the table, where a carbonation stone, there may be a little bit more variability.
That makes sense.
In that process.
I know a lot of those inline carb stone based processes require you have a hold tank after you pass that, just so it can kind of equalize a little bit under that exact premise. But the beauty of these membranes is once you turn it on, it's basically it's a quick ramp up period, but otherwise it's basically operating and running consistently.
Absolutely.
Well, perfect. Well, thanks a lot for kind of explaining a lot of this information. I think next up I definitely want to step out there and take a look at our equipment. We'll kind of walk through it and talk a little bit about it. But appreciate everybody's time.
Thank you.
So these are the contactors that we were just discussing, obviously sitting in the room over there. And, first thing that obviously you notice is immediately the compact nature of their size. These specifically are 8 by 20, so basically 8-inch diameter by 20-inch length inside of this essentially housing. And basically the membrane itself is inside the housing. The entire assembly is referred to as the contactor. But what's kind of the largest, what's the smallest contactors you guys make, and why would I go with a different size, smaller or larger?
So we actually manufacture as large as 14 inch in diameter by 40 inches long, and in the small side, more in the 2.5 inch by 8 inch size. So really, it's to accommodate a variety of different flow rates depending on the customer needs. So depending on the industry and depending on the process, it allows customers across a wide variety of applications to utilize our products. The other aspect is that customers can pick and choose, and they can use these contactors. They're modular, so you can add contactors in parallel to accommodate even larger flow rates. So you're not just limited to what the largest contactor can flow, but you can continue to add contactors in parallel to accommodate as large of a flow rate as you need.
Makes sense. And so, obviously these are shiny and bright and they're beautiful and they're stainless. So you guys, obviously with a little bit of background, you guys make different contactors for different industries. So these are stainless because they're made for food and beverage, so they have all the same type of fittings. So tell us a little bit about maybe some of the other materials that you guys would typically use in maybe matching industries.
The three main materials that we utilize is of course stainless steel for the beverage industry, but we also have housings that are more industrial in nature that are primarily PVC. PVC housings. We also have fiber reinforced plastics for the high purity applications of microelectronics.
That makes perfect sense. Well, I guess one other thing I wanted to point out. So we discussed this skid and specifically this design in a couple other videos, but we talked about it a little bit earlier. But there's your pre-filtration. That is going to be that high flow filtration. And the way this skid essentially works is you feed your water through the filtration. The water will flow, obviously now that it's been filtered, it will flow into the first contactor. In this scenario, we have 2 contactors in series. So the water is basically going to flow up to the first contactor, it's going to flow up to the second contactor, and it's going to flow out. Now that basically we'll be at we'll have the exact dissolved gas situation that we're trying to build, or in this case, we're trying to take it out. So ideally at this point, we've had all the dissolved oxygen removed. On the back side, or basically what you're not really seeing, but it's essentially mirrored with these caps here, that's where the gas is basically feeding. So the gas is feeding in to this top port on both, and the gas would actually be feeding in parallel because it just needs to distribute gas to each of the different contactors. And then there's a vacuum pump on the back side that's creating that favorable environment that we were talking about earlier, specifically what would be needed to allow basically the gas to move out of the water into the gas stream itself. But it's basically pulling vacuum on the tube portion where the gas is flowing, coming out the back in this exact port here. So again, beautiful, simple, easy to run design. To turn this on, I literally would turn that switch, it'll turn the vacuum pump on, I'd open the valve for the water to feed in, I'd open the valve for the gas to feed in, and you're ready to rock and roll. So anything else you wanted to add, take away?
think you have done a very thorough job of explaining. I think the only other point that I would make is that, like in this case, you have two contactors in series, particularly in beverage applications where the liquids tend to be a bit colder. You can add even more units in series if you need to reach single-digit parts per billion on your water.
That makes sense, and I'm glad you obviously brought that up. So, this system right here is designed. This is a rental unit of ours. We've done designs from really kind of the low end, maybe 10, 15 gallons, upwards of 500 gallons a minute. This was designed to kind of operate in a range of maybe 10 to 40 gallons, and really the goal would be to get the parts per billion level of the O2 down to closer to that single-digit level. In terms of a capability standpoint, especially compared to other technologies on the market, how does this membrane technology compare to if you used a tower? Are those other technologies capable of getting down to single-digit dissolved oxygen levels?
For towers, typically you can reach similar levels as with Liqui-Cel contactors, but it would require a deeper vacuum compared to the membrane technology.
Gotcha. So you don't necessarily need quite as much on the utility side to do with this technology. Well, that's excellent. I'm glad, obviously, you pointed out that this can reach down below 10 parts per billion comfortably. We personally have run this where it was accomplishing closer to 1 to 2 parts per billion. So, thanks a lot for your time. Thanks a lot for coming by. We appreciate you obviously spending time with us and spending time with everybody. Again, I'm Monty Pridgeon with Deutsche Beverage Process. We build the skids. This is Joe Cordano with currently with Solventum running the 3M Liqui-Cel products. They make the products that go in them. So, base of our relationship.